Hello everybody, this is Sam from HiPy. Today we're going to be looking at how to do analysis of variance. So analysis of variance is something that's very helpful if it's like a two-sample t-test as we did last time, but we do it with any number of groups. So we're going to be looking at a data frame which has cars. I'm just going to copy and paste this in. There you go. Enter, and then we're going to look at cars. Sorry about that. And we can see here we have a data frame full of data. It's the force applied to a driver's head on collision, depending on the car that they're in. So we have compact car, large car, and medium car. And we're going to be looking to see, and the null hypothesis for us this time is going to be, are the means equal? So the null hypothesis is all three of these means are going to be equal, so it doesn't matter what type of car you're in, the force applied to your head in a car crash is going to be roughly the same at least. So it's a little bit kind of dark, this test, but kind of like it's a nice example of what we're going to be doing. And a very simple way to get started and looking at if the mean is going to be equal is looking at a box plot of what's going on. So we're going to import matplotlib.plyplot as PLT, and then we're going to do a box plot of the data. So box plot, and then we're going to need cars compact. We're going to need cars medium. And we're also going to need cars large. And then if we do this, we're going to get a load of output here, which isn't helpful, and that's because I haven't actually shown the plot. And we can see here, yeah, they're roughly equal. And it's a little bit of an art, this, because we don't get any numbers out, but we can see there's a situation here at which the mean kind of like is around this 550 line, where it's within the realm of possibility that, yeah, that could happen. And I mean, obviously we can't make any definitive conclusions from this, but it's not like we have a kind of like a box plot down here or something. We don't have any kind of big kind of issues that we can just say, oh yeah, this is a foregone conclusion. We don't really we do need to do the test, but we can kind of know what to expect out of the test. So we can see that there is a little bit of variation here between the compact and the large cars, and we'd expect to see some kind of randomness in the data, but it's kind of like on one hand, while this 550 line does give us a kind of a good mean that we could say it's possible, we do have an obvious kind of a downward trend from the compact to the large car. So it's worth kind of like having this little discussion within yourself to say kind of questions to ask after, which are called post hoc tests, which are worth investigating, that we can kind of like know the questions to ask from this table, from this graph. So it's well worth doing it. So the test that we're going to be using is from scipy.stats. Let me write import correctly. Scipy.stats as stats, and then we're going to be using the f.oneway function underscore one way. And this is just a function that gives us the Anova functionality. So cars. In fact, if I be a bit cheeky here and just copy and paste this is a lot easier for me and for you, because you don't have to listen to me typing. If we just do this will work. Boom. And then we can see here we have our statistics straight away and our p-value. So this p-value might worry you. You might say, oh, but it's kind of like a little bit close to 0.5, or it's a little bit under 0.5. That means that there's about 33% chance of us getting this result of the sample based on our null hypothesis being true. So in other words, that means given that all the means are equal, we get this data. 33% might be a little bit low to you, and kind of like I would say you have some kind of common sense there, I guess. And intuition in that, yeah, 33% is quite low. You're saying kind of like if you roll a dice, you get a 1 or a 2. That's kind of like what we're talking about here. But in statistics, 33% is like fine. That might be a little bit unintuitive to you, but that is what we say in statistics, because again, while 33% might not seem a lot, if you roll a dice and you get a 1 or a 2, which is a 33% chance, you wouldn't say, oh, this dice is rigged. You'd only say this dice is rigged if you kept on rolling 1 or 2s for quite a long time. So I would always kind of think about p-values and be very careful about them in that way. because especially when I started with statistics, I'd look at a statistic like this and be like, whoa, there's no chance at all. These must be different, but we only care about p-values that are less than 0.1, and this is way more than 0.1. So we're going to say that the means are the same. So in the later part of this guide, I encourage you to look at the written resource for this. We look at the stats model's way of doing this, and then we also look at the two-way ANOVA, which is when we have two different categories to base on. So right now we just have the type of car, but if say we had kind of like the type of engine as well, we'd have 3 different types of cars, and then within that we'd have 3 different types of engines. We could do a two-way ANOVA, which is based on 2 different kind of categories. So we can look at that as well. But we also, look at that, look at the stats model's kind of documentation for that and the guide we've written for that. Then in the mini project, we are looking at the anger outputs for men and women, and if they're athletes or non-athletes. So the null hypothesis here is going to be the anger that you kind of show is independent of whether you are male or female, or an athlete or not an athlete. And then the null hypothesis is going to be there's some kind of dependency there. And that's what we're going to be testing in the mini project. So good luck on that. All the documentation is there in the guide, so you should be able to do it if you read through the written guide. This was just a very quick example of a quick and dirty way to do one-way ANOVA in Python, because that's all we've got time for. But hopefully I'll see you next time. We're going to be looking at statistical regression and the outputs that we can expect. And we will go through that next time, so I'll see you then.